6 miles beneath your feet. Right now, something is moving. Not a fish you've seen in an aquarium. Not a creature from a nature documentary. Something stranger. Something that scientists still can't explain. The pressure down there is so intense that if you were transported there right now, your lungs would collapse instantly. Your bones would shatter. Your body would be crushed into organic matter in less than a second. And yet, life exists there. Thousands of species. Millions of individuals. Entire ecosystems that have never seen sunlight. Never will see sunlight. And here's the part that keeps marine biologists awake at night. These creatures refuse to die. We've sent rovers to Mars. We've photographed Pluto from 3 billion miles away. We've mapped the surface of Venus through clouds of sulfuric acid. But the deepest places on our own planet, we've explored less than 5%. Less than 5%. We know more about the surface of the moon than we know about what is happening 7 miles down in the Pacific Ocean. And what we're finally discovering down there. It changes everything we thought we understood about life itself. To understand why these creatures refuse to die, we need to understand where they live. Let me take you down, layer by layer, zone by zone. First is the sunlight zone. From the surface down to about 200 meters. This is where life is easy. This is the ocean we know. Sunlight fuels everything. Plankton blooms and massive green clouds. Fish feed in schools so dense they look like living islands. Turtles glide. Whales sing. Coral reefs explode with color. This is the ocean of postcards and documentaries. The ocean that makes sense. But below 200 meters, everything changes. We enter the twilight zone, stretching from 200 meters down to 1 kilometer deep. The name sounds beautiful, but don't be fooled. Here sunlight is barely a memory, just the faintest hint of blue that human eyes can't even register. Photosynthesis stops completely. No plants, no algae, no green energy of any kind. Nothing grows here. And yet, things live here. Thousands of things. But they don't live the way life lives above. They've adapted. They've transformed. They've become something else entirely. The only food that reaches this depth falls from above. Scientists call it marine snow. Tiny particles drifting down. Dead plankton. Fish waste. Scraps of creatures that died higher up. It falls for days, sometimes weeks, before reaching this zone. To us, it's garbage. To the creatures of the twilight zone, it's survival. It's the only meal they'll ever get. And where there is food, there is life. But not life as we know it. The animals of the twilight zone look like nothing you've ever seen. Many of them are transparent. Completely transparent. The glass squid drifts through the water with organs barely visible. You can see right through its body. Its stomach floating. Its heart beating. Its brain processing. All visible through skin that chose to become invisible. The glass octopus is even stranger. Its eyes are the only solid feature. Everything else is ghost-like, barely there, almost imaginary. It moves through the water like a thought rather than a creature. Why? Why would evolution create animals made of glass? Scientists have theories, but no definitive answers. Maybe transparency is camouflage. In this dim, blue light, being see-through is like wearing an invisibility cloak. Maybe it's energy conservation. Pigments cost energy to produce, and down here, where food is scarce, every drop of energy matters. Why waste it on color when nobody's watching? But here's where it gets strange. While some creatures chose invisibility, others chose the exact opposite strategy. They chose to glow. Bioluminescence. Living light. Chemical reactions inside their bodies that create their own sun. To us, it's dazzling. Flashing dots. Glowing patterns. Entire bodies flickering like living lanterns in the darkness. But down here, light isn't for show. Light is survival. Some use it to lure prey. Some use it to find a mate. And some use it to disappear. This trick is called counter-illumination. From below, Predators can spot a dark silhouette against a faint shimmer of light from the surface. Easy target. But animals like the firefly squid have light-producing organs on their bellies. They adjust the brightness to perfectly match the glow from above. They erase their own shadow. They disappear by becoming the light. It's camouflage through imitation, making light to vanish into light. Other species play even stranger games. The bloody belly comb jelly glows deep red. Why red? Because red light never penetrates this deep. To any predator watching, red looks completely black, invisible. But inside its red belly, any bioluminescent prey it eats is completely concealed, hidden from predators that might otherwise see the glow inside its stomach. A private dining room made of invisible light. But the Twilight Zone holds a secret so massive that it remained hidden from humanity until World War II. Naval sonar operators during the war kept detecting something impossible. A false seabed. A layer so dense that their equipment thought it was the ocean floor. But every night, this false bottom would rise toward the surface, and every morning, it would sink back down. They thought their equipment was broken. They thought they were detecting enemy submarines. They thought everything except the truth. It wasn't the ocean floor at all. It was life. Every single night, as darkness falls above, billions of creatures rise from the depths. Lanternfish, squid, jellies, an entire army of the deep, climbing toward the surface to feed on plankton under cover of darkness. And every single dawn, they sink back down, vanishing into the gloom. Scientists call it the dial, vertical migration. It is the largest synchronized migration on Earth, bigger than the wildebeest in Africa, bigger than the caribou in Alaska, bigger than all migrations combined. More creatures moving than all herds, all flocks, all swarms in human history put together. And we only discovered it because we accidentally pointed our war machines at the ocean. The Twilight Zone is where the familiar rules of life begin to bend, where transparency is armor, where light is used to hide, where billions of animals rise and fall in a rhythm older than humanity itself. This is the threshold of the deep, the first layer of a world we still cannot fully explain. Past 1 kilometer, all sunlight disappears forever. We have reached the midnight zone, a realm stretching from 1,000 meters down to 4,000 meters. No dawn, no dusk, no sun, no moon, no stars. Just endless night, forever. Temperatures hover just above freezing. Pressure is hundreds of times greater than at the surface. If you were here, your lungs would collapse instantly. Your bones would crush. Your body would be reduced to organic soup in milliseconds. This place should be dead. This place should be empty. And yet, it is here that evolution becomes most creative. Meet the dragonfish. Unlike most creatures in the deep sea, it can produce red bioluminescence. To most eyes down here, red light is completely invisible, which means when the dragonfish turns on its red glow, it's like a sniper with a night vision scope. It illuminates its prey without ever revealing itself. It has its own private wavelength, its own secret color. Even more mysterious, its eyes are specially adapted to detect this hidden light. It's as though the dragonfish has invented a secret language seen only by itself. Other predators here are masters of disappearance. Some fish are cloaked in ultra-black skin. We're not talking dark gray. We're not talking black. We're talking 0.05% reflectivity. So efficient at absorbing light that if you shine a spotlight directly at them, they look like holes in the universe. Like someone cut a fish-shaped hole in reality. The light goes in and never comes out. And then there are the anglerfish, perhaps the strangest hunters in the deep. Every anglerfish you've ever seen in pictures, with the dangling lure and the massive teeth, that's a female. The male is born tiny, weak, helpless. His only job in existence is to find a female. In the complete darkness of the midnight zone, stretching thousands of miles, with no landmarks and no guidance, he has to find her. If he doesn't, he dies. If he does, he bites onto her body with special jaws. His enzymes dissolve their skin. Their blood systems connect. His organs wither away. His eyes atrophy. his brain shrinks until he is nothing more than a sack of sperm permanently attached to her body, nourished by her blood for the rest of his life. He becomes part of her. This is one of the most extreme forms of adaptation known in the animal kingdom. This is what survival looks like when the rules completely change. 4 kilometers down, we leave the open water and touch the bottom, the abyssal plain. This is the largest habitat on Earth. Covers more than half the planet. Bigger than all forests, all deserts, all mountains combined. And it looks like this. Miles and miles of mud. No landmarks. No reefs. No plants. Just mud, stretching for thousands of kilometers in every direction. Temperatures never rise above 4 degrees Celsius. Food is so scarce that a single meal might come once a year, once a decade, once in a lifetime. And yet, life not only survives here, it thrives. One adaptation is size. Many animals of the abyss are giants compared to their shallow water relatives. Giant isopods, the size of puppies, scuttle across the sediment. They look like roly-polies from your garden, but they're the size of small dogs. Amphipods, normally smaller than your fingernail, can grow longer than a human hand. Even the colossal squid, among the largest invertebrates alive, is thought to prowl these depths. Scientists call this deep-sea gigantism. Why it happens remains a mystery. Maybe bigger bodies are more efficient. Maybe it helps with pressure. Maybe it provides better defense against scarce predators. The truth is, we still don't know. Another oasis of life arrives when giants from above fall. A dead whale sinking to the abyssal plain becomes a rare jackpot. Within hours, scavengers gather. Sleeper, sharks, hagfish, amphipods, by the millions. They strip the flesh. Soon after, stranger creatures move in. Bone-eating worms called oxidacs colonize the skeleton, feeding on oils locked inside the bones. Entire ecosystems spring up on a single carcass, lasting decades until all that remains is dust. In this desert of silt and silence, life is slow. Creatures grow slowly, reproduce rarely, live for centuries. The Greenland shark, which can dwell at these depths, may live over 400 years. 400 years. This shark swimming right now could have been born when Galileo was looking at the stars. It could have been alive when Shakespeare was writing plays. It could have been swimming here, in the dark, while empires rose and fell and rose again. Time itself seems to move differently here. Below, the abyssal plain. The earth cracks open. Trenches, carved by tectonic forces, where one plate of the planet's crust slides beneath another. This is the Hadal Zone, named after Hades, the Greek underworld. It stretches from 6,000 meters down to nearly 11,000 meters below the surface. The Mariana Trench, the deepest known point on Earth. To put that in perspective, if you dropped Mount Everest into the Mariana Trench, its peak would still be more than a mile underwater. More than a mile. Conditions here are almost beyond comprehension. Temperatures near freezing. Pressure exceeds 1,000 times what you experience at the surface. 1,000 times. Every square inch of your body would have 8 tons of force pushing on it. And this ... This is where we find the snailfish. It looks like a tadpole, like something that would get eaten by a goldfish in a pet store. It's flabby, gelatinous, translucent. It has no scales, no armor, no weapons. It looks too delicate to exist in a bathtub, let alone at the bottom of the ocean. And yet, it is the deepest living vertebrate ever discovered. It thrives where no other fish can survive. How? Science is still figuring it out. But here's what we know so far. Its bones are soft, cartilage instead of hard bone, less to crush. Its cells are filled with special molecules called osmolytes that stabilize proteins under pressure. They keep everything working when it should be falling apart. Its skin is thin and permeable. It doesn't fight the pressure. It becomes one with it. It's not surviving despite the deep. It's surviving because of the deep. But even here, at the bottom of the world, we've arrived before the scientists could fully explore it. Recent studies found plastic fibers inside amphipods collected from the Mariana Trench, microplastics from our water bottles, our grocery bags, our synthetic clothes, the deepest place on Earth, the most remote location on the planet, and our garbage got there first. It's a sobering reminder that nowhere is truly isolated. Not even Hades. Along the trenches, where the Earth's crust cracks open, something even stranger happens. Hydrothermal vents, black smokers, chimneys spewing superheated water hot enough to melt lead, toxic chemicals, hydrogen sulfide, methane, heavy metals. This should be a death zone. This should be completely sterile. Instead, it's an oasis. Because down here, life found a completely different way. No sunlight, no photosynthesis. Instead, chemosynthesis. Bacteria that feed directly on the chemicals pouring from the Earth's interior, that convert poison into energy. And then everything else feeds on the bacteria. Tube worms with no mouths, no stomachs, no digestive systems. They're filled with bacteria. The bacteria feed them. Crabs that farm the bacteria on their claws. Clams that filter them from the water. Entire ecosystems powered not by the sun, but by the Earth itself. This changes everything. If life can exist here, powered by chemistry instead of sunlight, then where else can life exist? Icy moons like Europa and Enceladus hide oceans beneath their frozen crusts, warmed not by distant suns, but by internal heat, by gravitational forces pulling and stretching their cores, by the same kind of chemistry we find at our own hydrothermal vents. When NASA sends probes to look for life on other worlds, they're not looking in deserts. They're not looking on mountaintops. They're studying our hadal zone. They're exploring our hydrothermal vents. Because if life can thrive at the bottom of Earth's oceans, it can thrive anywhere. So why do these creatures refuse to die? The glass squid refuses to die by becoming invisible. It simply vanishes from sight. The dragonfish refuses to die by creating its own private light, a wavelength that only it can see. The anglerfish refuses to die by turning mating into permanent fusion, to becoming one forever. The giant isopod refuses to die by growing huge and slowing down, conserving every calorie. The Greenland shark refuses to die by living for 4 centuries, waiting out the years. The snailfish refuses to die by becoming soft when everything else gets hard, bending instead of breaking. The vent worms refuse to die by eating poison, turning death into dinner. Every single one of them found a way. Every single one adapted. Every single one refused to give up. And here's the thing that amazes scientists most. Every single dive into the deep sea brings back creatures we've never seen before. Creatures that break our rules. Creatures that shouldn't exist. More than 80% of our ocean is still unexplored. 80%. We've taken more than 500 people to space. Only 3 people have ever been to the Challenger. Deep. More humans have walked on the moon than have visited the deepest point in our own ocean. Nearly 3/4 of deep-sea creatures produce their own light. We know they do it. We don't fully know why. Hunting, mating, defense, communication, all of the above. We're still guessing. Some of these animals have been down here living exactly like this for hundreds of millions of years. They survived the dinosaurs. They survived ice ages. They survived asteroid impacts. They survived everything Earth could throw at them. And they're still here, waiting, thriving, refusing to die. So the next time you're having a hard day, the next time life feels impossible, the next time you want to give up, think about the snailfish. It lives at the bottom of the world. No light, no warmth, no comfort. Pressure that would kill you in an instant. Food so rare that a single whale fall is a celebration that lasts decades. And it just keeps going. It adapted. It found a way. It refused to die. Life wants to live. That's the lesson of the deep ocean. Life wants to live. It will find a way. It will adapt. It will transform. It will become invisible, or glowing, or fused together, or giant, or microscopic, or 400 years old. It will do whatever it takes. And maybe that's the most hopeful thing about our planet. that even in the darkest, coldest, most crushing places imaginable, life not only survives, it thrives, it dances, it glows, it refuses to die. The deep ocean is still full of secrets, creatures we haven't found, adaptations we haven't imagined, ways of being alive that we haven't conceived of yet. And somewhere down there, right now, something is glowing in the darkness. Something is hunting. Something is hiding. Something is living its life, completely unaware that up here, 6 miles above, we're only beginning to understand that it exists. The deep sea, the last frontier, the place where life refuses to die, and we've only just arrived.